international perspectives in its third seminar on bio-circular clean economy model in the bioenergy, biomaterial, and biochemical sector. Myself is Monteep Sriratana, Project Advisor with the National Research Council of Thailand and former Deputy Permanent Secretary of the Ministry of Natural Resources and Environment of Thailand, serving as moderator today. The United Nations Agenda 2030 and the Sustainable Development Goals represent an urgent call to action in a global partnership to end poverty, protect the planet, and ensure that everyone enjoys peace and prosperity. The Biocircular Green Economy Model, or BCG, is a strategy of Thailand to drive countries' economic and social development while promoting environmental sustainability. It is an integration of bioeconomy, circular economy, and green economy models. Bioeconomy involves the production of renewable biological resources and the conversion of these resources into value-added products. Circular economy aims at reusing and recycling resources, and green economy aims to keep the economy, society, and environment in balance, leading to sustainable development. So to open this event, we are honored to have messages from two key organizations that have made our seminar series possible. First, I would like to call Dr. Viparat Deong, Executive Director of the National Research Council of Thailand, to deliver a welcome message. Dr. Viparat, please.
Distinguished speaker and participants, greeting to all. It's my great pleasure and honor to deliver opening remarks for the seminar series on Thailand's bio-circular green economy model, awareness raising, capacity building, and international perspective in its third seminar on BCG economy model in the bioenergy, biomaterial, and biochemical sector. I'm deeply grateful to the partner organization of the National Research Council of Thailand, namely Mahidol University, in collaboration with the United Nations Resident Coordinator Office in Thailand, National Science and Technology Development Agency, Office of the National Economic and Social Development Council, Ministry of Foreign Affairs, and the ASEAN Institute of Technology. I thank all speakers and moderators and their respective organizations, namely Ministry of Energy, Bangchak Corporation Public Company Limited, United Nations Environment Programme, Petroleum Institute of Thailand Foundation, ASEAN Institute of Technology, and the United Nations University Institute for the Advanced Study of Sustainability, for their contribution in making this seminar possible. NRCT is the principal organization in Thailand which guided the development of the country and public policy by using research, including the integration and the administration of national research budget. Leading up to the concrete utilization, NRCT administers research work with professional standards by using moral principles. To reach achievement, NRCT employs these values and principles in its delivery of research and development programs in alignment with the UN Agenda 2030 and the Sustainable Development Goals, or SDG, including the implementation of the bio-circular green economy model in the country. The Royal Thai government has sponsored a number of events to introduce the BCG economy model to Thailand's private sector. Government officials and other stakeholders This seminar series will build on this event by sponsoring discussion between Thai and international experts on the BCG economy model, its intended impacts, and how experience, both domestic and international, may have lessons for BCG as implementation move forward in the country. The BCG economy model represents a strategy to drive the country's economic and social development. As such, is expected to provide further impetus for the implementation of the sustainable development goal. In addition, the BCG economy model is expected to be a focus of discussion at the 2022 Asia Pacific Economic Cooperation or APEC Ministerial Meeting chaired by Thailand. I am confident that the outcome of this third seminar on the theme of bioenergy, biomaterial and biochemical, as well as its subsequent seminars on other important key sectors of Thailand, will be valuable in learning the status of BCG economy model implementation in the country. Again, I thank our partner organizations and stakeholders, and I wish the seminar well. Thank you.
Next, I call on Ms. Gita Sapawal, United Nations Resident Coordinator for Thailand, to deliver an opening message. Ms. Gita, please.
Thank you, Khun Montip and Swadika. Distinguished experts, colleagues, and friends, I'm really happy to be joining you today for the third seminar, which focuses on bioenergy, biomaterial, and biochemical sectors. This topic is especially relevant as Thailand will soon be hosting the APEC meeting later this year and can take the lead in the region to promote a biocircular green transformation. The BCG economy model will contribute greatly to sustainable growth, biodiversity protection, and social inclusion in line with the SDGs. Bioenergy, biomaterials, and biochemicals are key pillars of sustainability, and the United Nations is working closely with Thailand on the advancement of these sectors by providing targeted policy recommendations, science-based solutions, and the introduction of best available technologies. Let me take this opportunity to share my views from a UN perspective about how we can add value. First, bioenergy. As electricity demand continues rising, the government has committed to boosting the share of renewables in the energy mix for the sake of a greener future and to deliver on its NDCs. Among the technologies being adopted with UN's technical assistance are small-scale biomass gasification plants which generate electricity from agricultural and wood processing waste in Thailand. Many small agricultural and wood processing operations produce biomass residues that tend to remain underutilized, making biomass gasification an ideal technology to support green energy. However, challenges remain, including a lack of expertise and training in rural communities. To that end, UNIDO helped set up pilot plants for using locally produced biomass residues to generate heat and electricity. Working with the Ministry of Energy and other stakeholders, UNIDO promoted biomass gasification as part of building capacities for community-driven renewable energy management in rural Thailand. The technology has made a difference in multiple rural communities in Chiang Mai, Kanchanaburi, and Nakhon Ratchasima. Current installed capacity remains low, but when it is scaled up sufficiently, small-scale gasification can increase energy autonomy in rural communities while reducing carbon emissions. The technology can have a transformative effect in villages and also aid Thailand to decentralize and diversify renewables towards a low-carbon future. Second, biomaterials. We are working on pilots for introducing and popularizing biopackaging materials such as bioplastics to reduce household and industrial waste. These materials are urgently needed as waste has reached chronically high proportions, with plastic and chemical pollution affecting the environment, including the oceans, while posing a threat to biodiversity. Waste assessments at 20 hotspot locations by UN Habitat and UNEP, in partnership with provincial administrations and cities, have shown that 3/4 of waste ends up in landfills and dump sites that are near saturation. Most of this waste is then left unrecycled. Our analysis also shows that average composition of household waste is 15% plastic, while in landfills it rises to 23%. This highlights the role that businesses and industry can play in recycling and reducing their plastic footprints. To do so, we need to introduce biomaterials for packaging to reduce environmental impacts nationwide. The Partnership for Action on Green Economy program, led by UNIDO and 4 other UN agencies, is also working on waste application tools to enhance sustainable municipal waste management. Third, biofuels. Biofuels can help boost sustainability and reduce Thailand's carbon footprint in line with the country's goal of achieving carbon neutrality by 2050 and net zero emissions by 2065. One important task is to address high dependency on fossil fuels by transportation within the Mekong region, which includes Thailand. As a result, UNIDO and its local partners have been promoting transfer of low-carbon bioethanol technology while engaging and training farmers, entrepreneurs, and specialists. And I know there are others today who are going to be speaking to this whole element of biofuels. The project has also informed the policy dialogue promoting bioethanol production from cassava in Thailand and other Mekong countries. As these examples show, we can harness scientific know-how and available technologies to accelerate progress on the SDGs to scale the BCG model. I'm looking forward to learning about other actionable practices from the distinguished experts during their speeches and panel discussions. Thank you very much, and Khap Kun Kha.
Thank you both Dr. Viparat Diong and Ms. Gita Sapawal for delivering cordial welcome and inspiring opening address. We are fortunate to have presentations by distinguished authorities and experts in the bioenergy, biomaterial, and biochemical sector. I have the pleasure to introduce our distinguished keynote speaker, Professor Dr. Pisut In Manakun, Secretary to the Minister of Energy of the Royal Thai Government. Professor Dr. Pisut is Professor of Environmental Engineering at Chulalongkorn University. Among his important positions, he serves on the National Committee of National Strategy, Quality of Life and Environment, and on the National Committee of Oil and Pollution Control and Management. Professor Dr. Pisut will speak on Biocircular Economy Model as Energy Transition Mechanism for Thailand Carbon Neutrality 2050. Let us hear from Professor Dr. Pisut In Manakun. Dr. Pisut, please.
Good afternoon, ladies and gentlemen. I would like to thank Mahidol University for inviting the Ministry of Energy of Thailand to give a chance to speak in topic of BCG economics models as to move forward energy transitions in order to achieve the target of Thailand carbon neutrality. I would like to introduce myself a little bit. I'm Professor Pisut Manakun. Right now, I'm the Secretary to Ministry of Energy, and also I'm the National Committee of National Strategies number 5 in terms of quality of life and environmental. I'm very pleased to share the experience on the NEP or National Energy Plan 2022 formulation to maintain our energy security, stability, and also sustainability by implementing the BCG model with the huge or interesting target for achieving Thailand carbon neutrality by 2050. If we focus on energy pathway, I think we all might know that today Thailand has an energy pathway to produce, store, import, export, and also consume these all energies. However, after we came across the COVID-19 recovery period, the energy has grown rapidly, which lead to higher energy consumption at this moment. Therefore, energy transitions could be the important goal for Thailand in order to ensure our stable security and sustain the energy supplies. If we focus on energy pathway in Thailand in terms of input, process, and output, we can see that the energy management play the important role to analyze, balance, and to make the most efficiency to energy consumption for Thailand. This not only push us forward to become a decarbonized country, but also encourage us to encounter and overcome global crisis at this moment. So I would like to emphasize a little bit that for all of us as the consumer who consume the energies, we should try to adapt our business as usual and our behavior in order to tag along with this energy crisis situation right now. If we focus a little bit more in depth on energy situation in Thailand, Thailand we have right now 6 interesting energy situation. Okay, but overall you can see that the highlight is the demand side or the consumption rate, not only for the gas, oil, the LPGs or electricities. We can see the increasing that huge. Meantime, okay, we can notice also that right now we have the problems about the Myanmar and the Gulf gas production that was declined by 20 to 30%. Therefore, we are extremely affected by problems, okay, by the surge of energy price and high demand of the long-term contract and spot LNGs. So, with the current global energy crisis, this is a main factor for Thailand to consider as opportunities, in my opinion, to focus on strategic transformations plan toward sustainable consumption and production in order to go on to the low carbon economy and of course pro environmental behavior change. If we focus on the Thailand climate action, our Prime Minister Prayut Chan-o-cha announced at the COP26 in Glasgow last year the target of the Thailand that we have 3 important issues interesting. The first one, the NDC target to 40% in the year 2030, and also in the year 2050 is about carbon neutrality. And then for 2065, our country will move on the net zero emission with technical and financial support. In this case, the BCG economic models will be an important mechanism, in my opinion, to support Thailand goal by implementing capacity building program and cleaner energy technologies, enhancing people's understanding and awareness on how to become environmental friendly energy consumer. Moreover, for the BCG economics model can provide us also the great opportunities in order to achieve the new S-curve industry via research and development, and also create the appropriate innovations and technologies. Currently, Thailand is formulating the long-term strategy on climate change mitigation and action plan to reduce greenhouse gases emissions. So we will make our great effort in driving several measures. For example, increasing share of renewable energies, increasing the proportion of EV or electric vehicle, promoting waste to energies and waste management through the BCG economics models. Now we have come to our main topics. Okay, after I try to introduce a little bit for you all, BCG in energy context. The first one for the bioeconomy, which involve the production of bioenergy resources such as crop and farm residuals by using smart technologies and innovation to gain more output and minimize cost. Next, if we go on to the circular economies, aim at reusing and recycling various material resources and converting into value-added energy products, such as the electricity or the biogas, for example. And lastly, for the green economy in terms of energy context, we can see that this one can help us to balance the economy, society, and environment to achieve the triple bottom line: profit, people, and planet, by integrating the innovation energy technologies to support smart energy supply and consumption system in order to sustain and develop our country sustainability. So these all B, C, and G, we can see that can incorporate with the concept of the energy transition that right now our ministry focus on. And also these economic activities are needed to be supported by science, technology, and innovation to enhance the competitiveness of players along the value chain. Innovative policy and productive, legal, and financial measures will be the final pieces that are needed for BCG model. And then if we take a look the update BCG initiative in Thailand, in order to achieve carbon neutrality and net zero emission goal, in my opinion, BCG is a big key player to accelerate clean and green energy transition in Thailand. BCG model provides the idea how we can utilize the bioenergy resources by using smart technologies and produce energy for the commodities and to enhance energy efficiencies in the meantime. This will help creating energy security, raising income for the communities, lowering the cost of energy, promoting better quality of life, and also eliminating waste or emissions while lowering carbon dioxide emissions is quite interesting. Next, I would like to give you 2 or 3 examples of BCG model in energy context. The first one is the community power plant. This is a concept where the communities co-own the renewable energy power plant and participated in sustainable producing, consuming, and selling electricity to the grid. As we know, the objective of these projects are to help the communities to earn extra income from owning the power plant and sell agricultural waste as a fuel, while investor as a joint venture will operate the plant and supply electricity to the straight grid. So for the concept of the commodity power plant, we can imagine that this one related or incorporate with the BCG economic model, because we basis or we focus on the bio-base or biodiversity that we have. Meantime, we try to incorporate the concept of the circular economy that we have the agricultural waste, okay, from our farmer and livestock farm. If we can combine these two concepts for the B and C together, you can see that we can generate more income as the economics model from this BCG mixed with the energy context. Let's move to the second concept or second examples. I would like to mention a little bit on the smart farming idea. As we know that right now, Thailand, we have the huge or interesting biodiversity. However, for the smart farming concept, is still the missing pieces in my opinion. Let's think about if we can operate or design, for example, the sandbox projects, and then we combine this energy concept to this one, as we can see from, for example, the BCGสีแสงธรรม model, or we can use this kind of project to try or implement the new technology and innovation in electricity billing calculations. In the same time, we can test and experiment the energy storage, microgrid, and also load aggregator system. After these two examples that I try to provide you some idea. Moreover, in my opinion, the BCG economics model for the biomaterials and the bioeconomies. The National Biobank is also the key part for our country to complete the BCG economics model. Moreover, smart agriculture industry should be another point should be implementing in our country to complete the BCG economics model together with the energy transition. The biomaterial, for example, the bioplastic is also the part that in my opinion is very interesting. Okay, and the last one, if we do more research, on local forestry species, we can go on with the carbon sinks via the forestations in order to complete or go on with the carbon capture and storage in our country. For adapting of 41E policy in energy sector, I would like to emphasize the future energy trend for Thailand is green energy transitions. Currently, we are working toward our preparation of National Energy Plan 2022 with 41E strategies consisting of decarbonizations, decentralization in energy supply side, such as transforming to use renewable energies and grid modernizations, digitalization and electrifications by adopting smart technologies and innovations such as Internet of Things and sensors. And the last one, the regulation in connection with energy through effective mechanisms such as green tariff and ESCO concept. Several key measures and action to promote green investment and the use of renewable energies are the key themes of this plan, with go green with energies, securities and competitiveness for sustainable energy futures. Since Thailand is becoming environmentally oriented, the establishment of BCG model and 41E policy could lead us to increase future economic growth and align it with sufficiency economy philosophy or SEP. Build resilience, environmental, and effective in risk management. Furthermore, This strategy could also eventually create pro-environmental behavior and also the thing that we call new Thai paradigm shift. At last, I would like to highlight that the integration of 4D1E policy and BCG economics model are important strategies and key players for Thailand to promote sustainable agriculture, green energies, and responsible consumption and production or SCP, while ensure the sustainable utilizations of biodiversity and protect the environmental and ecosystem so that no one will be left behind with completely correspond to sustainable development goals. Ladies and gentlemen, I strongly believe that energy sector policy such as 4D1E integrated with the BCG economics model will not only enhance the economic growth to gain greener GDP for our country, but also efficiently drive our country toward carbon neutrality in 2050. Meantime, can fostering the pro-environmental behavior among Thai people as well as contributing long-term Thailand inclusive growth for sustainer and better Thailand for the next generations, for us and for all. Thank you very much.
Thank you, Professor Dr. Pisut, for providing us an overview of a roadmap towards Thailand carbon neutrality by 2050, utilizing the BCG economy model as a mechanism to support Thailand's goals by implementing capacity building program and cleaner energy technologies, enhancing people's understanding and awareness on how to become environmental friendly energy consumers. It is an excellent keynote to the presentations and discussions that will follow next. Our next speaker is Ms. Sandra Avilas Moneri, who is currently Acting Head Knowledge and Risk Unit, Chemicals and Health Branch Economy Division, United Nations Environment Program or UNEP. Ms. Sandra Avilas Moneri, among her important tasks, leads work on chemicals in products, chemicals and plastic, sustainable and green chemistry, and the Global Mercury Partnership. She has worked on sustainable consumption and production at UNEP. She oversaw the eco-innovation portfolio, engaging all sectors, including private sector and SMEs, towards sustaining value chains and circular economy, where she focused on circularity, plastic, building, and electronics and textile sector. As development economist, her area of expertise in chemicals, sustainable consumption and production, and disaster preparedness. Ms. Sandra will speak on clean and sustainable chemistry. Ms. Sandra, you have the floor, please. Please turn on your microphone. And please unmute.
Can you hear?
Yes, yes.
Yes, okay, perfect. Wonderful. Apologies for the technical hiccups. So thank you very much for inviting me in this seminar, and I'll be focusing my intervention around green and sustainable chemistry, work that we have been conducting at UNEP for the past 3 years. And that actually has started in Thailand at the intersessional process for Beyond 2020 on chemicals and waste that took place in September 2019, and where a technical briefing was provided on green and sustainable chemistry. Just give me 1 second to share my screen. Could you confirm you can see the screen?
Yes, yes.
Okay, wonderful. Thank you very much. So just to start with the reasons why we need green and sustainable chemistry, and we have conducted a Global Chemicals Outlook 2 and released in 2019, which found out that business as usual in the area of chemicals is not an option, and there are more and more hazardous chemicals and other pollutants that continue to be released and that are a big use to humans and the environment. In the meantime, the market is growing, and in particular in chemical intensive industry sectors. And finally, there is also a growing consumer demand, but there is also a possibility for green and sustainable chemistry education and innovation that could be drivers for change. So if we manage to scale these up through enabling policies, through reaping the potential benefits of chemistry innovation for sustainable development, then we could achieve the sustainability, and we could certainly support the discussions related to biochemicals in the BCG model. So just highlighting few elements and benefits of green and sustainable chemistry and how it contributes to the discussions on bioenergy, biomaterial, and biochemicals. There is clearly, through chemistry innovation, the possibility of innovation in chemistry, but also innovations in chemical engineering science and in related areas such as product development. So green and sustainable chemistry in that case supports circularity in areas such as product design for circularity, reduced resource used, alternative feedstocks, which relates to biomaterial, and waste conversion technologies, including some that were presented by previous speakers. It also has a benefit and potential effect on climate change through possibilities for energy storage or improve renewable energy generation, less energetically intensive processes, or carbon dioxide being seen as a feedstock. And finally, it can have an effect, a beneficiary effect on less pollution through biodegradable materials. And I've heard mention of bioplastics in the previous intervention. We'll come back to that. Non-toxic alternatives to chemicals of concern, so that there are no release of harmful chemicals such as the POPs, the persistent organic pollutants, and alternative non-toxic catalytic materials as well. So these are promises from green sustainable chemistry, and UNEA, the United Nations Environment Assembly, in 2019 requested UNEP to work on manuals for green and sustainable chemistry. And we presented the manuals in March this year at UNEA. and the Environmental Assembly and its member states welcome the Green and Sustainable Chemistry Framework Manual and its executive summary, highlighting the crucial importance of environmentally sound innovation and encourage its use as appropriate. So given the strong links with the topic of the seminar today, I wanted to provide an overview of this framework manual. So the objective and the idea is to foster general learning, reflection, and scaling up action based on common understanding of green and sustainable chemistry. And the manual is organized through different chapters. One part that is looking into the why and the what. So why green and sustainable chemistry and what does that mean? And then the how. And the how including the enabling instruments and policies, a clear emphasis on the life cycle thinking that is extremely important to make sure that we don't have regrettable substitution and regrettable alternatives. Corporate sustainable strategy so that the private sector is fully embarked. Enabling sectors and programs, and I saw a message in the chat from a colleague from UNESCO, a very strong element of green and sustainable chemistry is the education and how chemistry is taught, as well as collaborative research and innovation and sustainable business models. And then metrics or how we can assess and how we can report, and some suggestions and ideas for metrics and sustainability assessments and reporting. I think as in the BCG model and as in efforts towards sustainable development, the engagement of stakeholders is really essential. And in green and sustainable chemistry, we really encourage all relevant stakeholders to be working together so that innovation can be sustainable and beneficiary to all. This is where I will be spending a little bit more time on the 10 objectives and guiding consideration for sustainable chemistry, and highlighting that what's guiding is making sure that it helps promoting innovation that can unveil the full potential of chemistry so that it is compatible with and it supports the implementation of the 2030 Sustainable Development Agenda. And the objective is that these 10 objectives are guiding consideration inform green and sustainable innovation in chemistry and help assess existing practice throughout the value chain of chemicals and of products. It's in a way what we often say could be put in a wall and just check against these 10 objectives whether the innovation and the policies related to chemistry are green and sustainable. So we have 10 objectives. The first one is very specific to chemicals, and it's minimizing the chemicals hazards. And making sure that the properties, the hazard properties for using material, products and production are benign. So it's also called benign by design. The second objective is avoiding the regrettable substitution and alternative. And it's really about chemicals, but it's about the material, it's about the product innovation, ensuring that it does not create trades-off. The third one is about sustainable sourcing and resources and feedstocks, so very closely linked with biomaterial. And again, making sure that it's not creating trade-off, and I'll focus on this one a little bit afterwards. Objective 4 is on sustainability of production processes. So to improve resource efficiency, to improve pollution prevention, to improve waste minimization in industrial processes. The 5th objective is on products and ensuring that the use of green and sustainable chemistry innovation can help create sustainable products and consumption with minimized chemical hazards. The 6th objective is on chemical release and pollution. So that throughout the life cycle of chemicals and throughout the life cycle of products, there is a reduced chemical release into the environment, air, water, soil. The 7th objective is on enabling a non-toxic circularity. So using chemical innovation that supports non-toxic circular material flow and sustainable supply and value chains throughout the life cycle. So in other words, it is essential to increase recycling today, but it is also very important to ensure there are no chemicals of concern, problematic chemical in the material that is being recycled. Ideally through design of the material and products, this could be already avoided in the first place. The 8th objective is about maximizing the social benefits, and I think it resonates very well with the elements related to inclusive growth and inclusive development that were highlighted by the Ministry of Energy, among others. And considering the social factors, the standards of ethics, education, and justice in chemical innovation. The 9th objective is on the protection of workers, protection of consumer and of vulnerable population. So safeguarding the health of workers, consumers, and in particular vulnerable group in formal and in the informal sector. And the last objective is on developing solutions for sustainability challenges. So making sure that the chemicals innovation, so in the case of the seminar today, the biochemical innovation, help address the societal and the sustainability challenges that we are facing. So I mentioned I would focus a little bit further on the objective 3. Sorry, 7, 3 and 7. So this is objective 7 on the non-toxic circularity, and just highlighting some guiding ideas or considerations, like making sure that as much as possible, the value of materials is maintained during the product life cycle, and it can be through lifetime extension of products. It can be through recycling. As I commented, eliminating toxic compounds in the project in the first place, ideally in the design, and ensuring that there are materials that can rapidly mineralize in the environment. This objective 3 is related to sustainable sourcing of resources and feedstocks, and we've heard reference to biomass, and in particular to biomass residues, which is a very interesting area for the BCG model to unfold. And here what we really are encouraging is the use of sustainable and renewable resources, materials, feedstocks, including recycled chemical feedstocks, as well as bio-based feedstocks. However, we really wanted to highlight some important sustainability consideration when looking into bio-based feedstocks. Recognizing the need for agricultural land to produce food, making sure that there is limited destructive impact of bio-based feedstocks on forests and ecosystems. So as much as possible, ensuring that the residues are being used, and also consider the nature of chemical being produced with the biomass. But this is absolutely relevant for stakeholders that are in the mining or in the processing, in the farming, as well as for chemists, for engineering, for sustainable chain manager or engineers in the chemical industry. And of course, for the governments and the regulatory stakeholders. And it further highlights how important it is to be working with all the stakeholders in the value chain to support the objective of the BCG model. And one last point I want to highlight on bio-based related consideration is the possibility of having biorefinery technologies to ensure that basic chemicals traditionally produced through energy intensive and polluting petrochemical refinery technologies. And there are a number of opportunities for bio-based chemicals, including as plasticizers. So we heard about bioplastics, including for water grease and dirt repellent, flame retardant, biopolymer or surfactants. However, it's really important to look into the biodegradability and to highlight that unless there are specific and proper conditions for biodegradation that are met, such as, for example, composting plants, biodegradable plastics would not necessarily advance sustainability. So just making sure that the conditions for biodegradability on the diverse biodegradable types of plastics are met. So I hope that has been an interesting contribution to the biochemical angle of the BCG model application and to biomaterial as well. And I really look forward to the discussions that will unfold to support discussion on challenges and opportunities. And I look forward to hearing the further panelists on a very interesting seminar already. Thank you very much for the invitation.
Well, thank you very much, Ms. Sandra Averas Monelli from UNEP for sharing important aspects of green and sustainable chemistry as integral elements of BCG. And also thank you for introducing the UNEP Clean and Sustainable Framework Manual. This will be very important and benefit for our BCG action plan in the future. Our next speaker is Dr. Kuruchit Nakornthap, Executive Director of Petroleum Institute of Thailand Foundation. Dr. Kuruchit, former Permanent Secretary of the Ministry of Energy and Director General of Department of Mineral Fuels, Ministry of Energy. He is Vice Chair of the Bioenergy Materials and Chemicals Subcommittee under the BCG Model Steering Committee. He has experience in various leadership capacities, including as Director and Chairman of the Board, Electricity Generating Authority of Thailand, Chairman of Energy Affairs Committee, and member of the National Reform Steering Assembly, and executive member of the National Research Council of Thailand, among others. Dr. Kuruchit will speak on bio-circular clean economy model in energy, material, and chemical sectors. Let us hear from Dr. Kuruchit. Dr. Kuruchit, please.
Good afternoon. I'm very honored to be participating at this third series on biocircular green economy model, awareness raising, capacity building, and international perspective. My name is Kuruchit Nakhonthap, Executive Director of Petroleum Institute of Thailand. I'm also the Vice Chair of the Bioenergy, Materials and Chemicals Subcommittee under the Thai National BCG Model Steering Committee. Today, I will talk about biocircular green economy model in the energy, material and chemical sectors and what Thailand aspires to do. First, want to touch a little bit about sustainable development. This definition of sustainable development, I got it from the UN report some 30 years ago under the Brundtland Commission's Our Common Future report. And it aptly defined sustainable development as meeting the needs of the present without compromising the ability of future generations to meet their own needs. Very touching, and it means that our generations, although we have to feed ourselves, we should not be over-aggressive and prevent our future generation from feeding themselves and breathing fresh air. That's the gist of this definition of sustainable development. Next come the UN 17 Sustainable Development Goals, of which I think I can identify what BCG economic model in Thailand are trying to do and conform with some of these 17 SDG goals. First and foremost is reduction in poverty, eliminate hunger, try to find affordable and clean energy, decent works and economic growth for the nations, reduce or lessen the social inequality, responsible consumption and production that also relate to circular economy, and finally, climate change and climate action. Our BCG model actually stands for bioeconomy, circular economy, and green economy. And this economic model for sustainable development. In Thailand, we are embarked on a post-COVID-19 development strategy to reduce inequalities and eradicate poverty by moving the nation forward and leaving no one behind. And the principle that we want to apply is sufficiency economy or sufficient economy philosophy for sustainable development, to create strength from within the country while also connected to the world and moving forward as a nation with no one left behind. In Thailand BCG model post-COVID-19, we will apply sufficiency economic principle with the SDG goal to drive the strength that I think Thailand have internal capability. That is to attain food security, health, medical security, energy security, employment security, and sustainable natural resource and environment. Focus more on what we are trying to do with the BCG economic model and strengthen from within. I would like to touch on two key areas in the time slot that I have. One is on food and agriculture. The other is on energy, materials, and biochemical, of which I'm a part of. This BCG model will capitalize on the biodiversity of the nation as well as cultural diversity, applying policy and management, science, technology, and innovation, and encourage participation from all sectors of society. First, on the agriculture and food. Our pain point is that we have in the agriculture sector a labor force of over 30, almost 1/3 of our population. But this 1/3 of our population only produce 6% of the GDP. Thailand import over 58,000 million baht worth of fertilizer, yet our agricultural efficiency is still lower than our neighbor by 3 times. So we need to create more productivity, less cost in doing our agriculture, and also encourage a high value export. We would introduce under BCG model new product champion, new economic plans and animal. We will use technology in agricultural map platform, economical animal vaccines, smart farming, startup and business, and high value herbal product. So we will try to achieve smart farming using less space, emitting less greenhouse gas, and being more productive, and with high value yields. On the energy, chemicals, and biomaterials, I think Thailand's strength and our history have been our agricultural platform. We are agricultural-based country, but our pain point is that we are used to be top exporter of sugarcane, rubber, and palm oil, but somehow the price of these 3 crops keep fluctuating and going downward in a downward trend. We also a nation that import more than almost 2/3 of our energy needs. And we have a lot of agricultural waste, 40 million tons to be exact, that can be used as a biomass to produce energy. So we aim Thailand to move toward becoming a biorefinery hub of Asia. Our product champion is biofuels such as ethanol to make gasohol and biodiesels. These can be also manufactured not only from agricultural product directly, but also from industrial waste. Biomass from various agricultural waste can be turned into fuel to produce electricity, bioplastic and degradable compound, and also to become a regional hub for biorefinery industry. In our BCG model for energy, material, and biochemical sector, we would target energy crops and in agricultural waste, putting technologies and investment promotion to turn it into a power plant, biorefinery pilot plant, and in the future, perhaps hydrogen power plant. And the outcome would be biofuels, such as ethanol and biodiesel, bioplastic and biochemicals, and one day a hydrogen-based fuel. Government policies will encourage more technology transfer and innovation into the biorefinery pilot plant at the EECI, or Eastern Economic Corridor of Innovation in Rayong province, in the tune of over 3.4 billion baht, starting at pilot plant on biorefineries to create various products to test the market. And to be more to the point, under my subcommittee on bioenergy, material and chemicals, we have 4 quick win or roadmap to do something quick to achieve our target. The track 1 is the market opportunity for bioproduct using carbon credit and carbon pricing mechanism. Track 2 is BCG energy resource to promote community economy for the rural people. And track 3 is a value-added product from agricultural products and waste. Track 4 is innovation in biorefinery to promote value-added products and services and small, medium enterprises. All the underlining box are the business driver and enablers. I would not dwell much on it. Starting with the first quick win project called carbon pricing mechanism through carbon credit and carbon offset program. The target is to create a reforestation of up to 0.512 million hectares by the year 2027 by creating carbon sinks or CO2 absorption or reduction up to 9.6 million tons of CO2 equivalent. The means of doing this is by creating incentive for the private sector to plant trees on the government lands in exchange for carbon credit. And over the past 1.5 years, we have made excellent progress on this program. The government agency responsible for the land on reforestation on coastal forests have all issued regulation that will provide support on this allocation of carbon credit generated by reforestation, whereby up to 90% of carbon credit will be allocated to the private sector who invest in tree planting in government land, and government would only retain 10% of that carbon credit. And I'm pleased to say that at the end of April of this year, just one department of marine coastal resource that responsible for coastal watershed forest have received pledge of tree planting in coastal forest of up to 3.2 million rights, or about half a million hectares, that capable of generating carbon sinks of up to 2.9 million ton equivalent per year. That's 0.5 million hectare, not 0.5 hectare. Okay. And I think planting tree, there's no doubt about it that the main purpose is to preserve biodiversity, preventing flood and drought, but it also helps combat global warming and reduce climate change problem by creating carbon sinks that can be used to offset or abate carbon emission. The second quick win project on the energy and material and biochemicals is on clean and circular green energy. We will study the policy recommendation on biofuel for transport that will synergize with the ZEV promotion, electric vehicle promotion, and in turn help reduce fossil fuel consumption and apply innovation to add oleochemical value to domestic agro-based industry. This slide shows the research that we have done on the life cycle modeling of vehicle using various fuels, and in turn compare on which vehicle in the end emit the least CO2. And we will make policy recommendation to the government that will also promote biofuel that is produced domestically. Also to capitalize on oleochemical research and oleochemical for sustainable development, we have identified these 7 products that can be manufactured domestically to fit this BCG model. That is bio-loop base, biotransformer oil, methyl ester, bio-loop and bio-grease, bioparaffin, biopesticide, and rubber process oil. The next project is on community energy. We aim to promote and introduce renewable energy production for community consumptions by means of technology support, assessment of potential, giving low interest loan and incentive for private sector to help villagers to become a prosumer of electricity and biogas that will help them be more self-sufficient in energy requirement. So the plan is simple: low interest loan to support renewable energy technology transition in rural community, support matching fund for private sector who use renewable energy to help community, and technology transfer and skill transfer. So this is a plan to introduce energy in the community. I won't go much in detail. The next project is to introduce smart grid and energy trading platform in the rural area, whereby there are potential for producing renewable energy within the community, being it from solar rooftop or biomass, and then trading from one that can produce energy with the one that need energy without government intervention through the energy trading platform. And we have introduced this pilot project in the Ubon Ratchathani province, solar rooftop 48 kilowatt with the building energy system, storage system of 30 kilowatt. And we hope that in the future, this energy trading platform would allow peer-to-peer trading of electricity within the community, whereby energy could come from biomass, biogas, and solar rooftop. So we aim to expand this further in the rural community under the sandbox of the Energy Regulatory Commission. And the last one I want to touch on is the biorefinery industry. As I said, Thailand is a country with agricultural history. We are fortunate that we have abundant agricultural resources. And I think that to uplift the income of the agricultural sector, we need to apply technology and producing high value products. So this biorefinery industry would aim to apply research and development, design engineering and prototype industrialization, standard and regulation, marketing and logistics to create a product that is environmentally friendly and economic to the consumer. So that is why we have invested in this EECI, Eastern Economic Corridor Innovation Hub with NASDAQ to promote a pilot study on biorefinery that aim to produce from the abundant agricultural resource using homegrown research and development and applying a standard of good manufacturing products to create the various type of products that hopefully will help replace the product that come from the fossil fuel and petroleum in the future. So these are some of the products we are in the pipeline for research and development in the power plant. Due to the interest of time, I would just skip this. And finally, I think I would like to touch on that BCG would not be complete without the concept of circular economy. And what is circular economy principle? It aims to design out the waste and pollution, keep product and material in use longer, regenerate the natural system. So we have to use new way of thinking when we make product, manufacturing products. Is it necessary? Can we do it with less? So by reduce the material in the design phase and use the phrase reduce, reuse, and recycle. And in industry, they have more words like repair, refurbish, and remanufacturing. So these are the concepts of circular economy. If we want to preserve the world that we know for our children and future generation, we have to be more circularity in our way of doing business and in our way of living. So that's the end of it. And I would like to end that since I'm from the energy sector, that we cannot focus on any one issue. We have to focus on related issue, and that is energy security, availability, and reliability, energy affordability and fair price, and environmental sustainability, that is cleanliness and renewable energy. So that's all. Thank you.
Thank you very much, Dr. Kuruchit, for elaborating on the SDG model as Thailand's economic model post-COVID-19 and linking it with the sufficiency economy philosophy and the SDG framework. Dr. Kuruchit guided us through the various initiatives in several focus sectors in Thailand and stressed the importance of policy and management, science, technology, and innovation, and participation from all sectors. Our next speaker is Professor Dr. P. Abdul Salam, Professor and Chair of Sustainable Energy Transition Program, Department of Energy, Environment, and Climate Change, School of Environment, Resources, and Development, Asian Institute of Technology. Professor Dr. Salam has many years of international experience in research, consultancy, and capacity building in the areas of bioenergy, including biomass, biofuel, biogas, waste to energy, renewable energy, energy efficiency, energy, food, water nexus, and climate change mitigation. He has published books and numerous internationally referred journal articles and conference papers, and a number of development and industry reports. He also has some years of working experience as general manager and chief design engineer of an energy service company and carried out a number of consultancies, feasibility studies, and implemented many projects. Professor Alam's talk is on advances in bioenergy in the context of bio-circular clean economy model. Professor Salam, you have the floor, please.
Thank you. Thank you for having me. Let me share my presentation. No, sorry. Find my presentation. Give me 1 minute. Yes, can you see my presentation?
Yes.
Okay, thank you. Once again, thank you for having me, and good afternoon, ladies and gentlemen. I have a little bit of sore throat. I hope you can bear with me. And while the previous speakers mainly discussed about the BCG model and the bio-based materials and the various aspects, here mainly I'll be spending a few minutes with you all, mainly discuss about some of the salient features of the bioenergy. And as you can see that some of the recent advances in the bioenergy, I'll spend a few minutes to discuss with you all. And bioenergy, again, plays a very important role already. Bioenergy provides around 9 to 10% of the global energy demand. And of course, the around 85% of this bioenergy is used for the cooking and heating in the buildings, or more than 50% of the bioenergy is used. Around 2.6 billion people in the world is still using the biomass for the cooking purpose. And of course, there are around 6% of biomass is currently used to generate electricity. And of course, around 7% of the biomass is used to produce the fuel for the transportation. So biomass is already playing bioenergy playing a very important role already in the world. Now, if you look at in the case of the Thailand, again, bioenergy is the largest energy source if you consider among the renewables, and again, third major energy source, and mainly used for the cooking, process heating, and the electricity generation. And some of you are here may be very much familiar with the Thailand's alternative energy development plan. As per this ADB, by 2036, the Thailand is planning to have around 29,000 megawatt from the renewables. Out of this, around 30% will come from the biomass and waste, and also almost 100% of the heat generated from renewable, that is around 26,000 kiloton of oil equivalent, will come from the biomass and waste. And also, as many of you know, that the biomass is very much used to produce the bioethanol and biodiesel, etc. in Thailand. So again, bioenergy, biomass has its presence very much felt in Thailand already. Now, what will happen in the future? Considering the future biomass usage, and again, many of the finding says that modern bioenergy can support the decarbonization of all the sectors, And as you can see from here, by 2050, we can provide 20% of the total energy use in industry. And also the bioenergy is going to be the one of the few renewable options available for the aviation industry. And as you can see here, the compared to 2019, the bioenergy usage is going to be very much increased in all the sectors, whether it's the building sectors or transport sector, industry sector, and others. And there are most of the studies suggest that bioenergy usage is going to increase in the future. Now, of course, when we talk about the bioenergy, and of course, this bioenergy is coming from the biomass. And between biomass and the bioenergy, there are these technologies which are used to convert the biomass into bioenergy, or for that matter, biofuel or the electricity, etc. So there are a number of technologies already available. Some of them are very well developed, some of them are in the research and development stage. But the major issue with the biomass and the bioenergy is, unlike the other fuels, biomass has a lot of its own issues. For that matter, we can say that there are a number of different types of biomasses available, and their shapes and size varies, and their characteristics are different. And of course, compared to the fossil fuel biomasses, another important issue of having more and more the water content and the ash content, etc. So the biomass has its own problems and issues. That is one sector, one issue. The other side, there are a number of technologies available and developed. So there is no one technology which is fitting for all the different types of biomass. So it is very important to know the characteristics of the biomass, so that one can identify and select and use relevant and the suitable technology for converting the biomass into the particular energy or fuel or electricity, etc. And there are different technologies. As I mentioned, there are thermochemical and biochemical processes, pyrolysis, gasification, liquefaction, and there are many. And some of the technologies are, well developed, and of course, some are under the research and development. Now, just for the sake of completeness, and again, I don't want to talk much about the basics or more engineering things here, but the viewer should realize that basically there are a number of technologies available. Let us quickly go through this list. It is very important to have an idea. So when we have the biomass, as I mentioned, it can be any, like for example, forest residue or any agriculture residues, or even it can be municipal solid waste or any other solid waste, or it can be algae produce, or anything can be considered here as the biomass. Now, the thermal chemical conversion, the well-known technology is the combustion. We all are familiar with the burning of biomass. So many of us have seen that, especially the traditional cook stoves, where biomass or fuel wood is simply burned and the heat is produced, and that heat is used for the cooking purpose. So now the combustion is the well-established technology. Of course, you can get the heat, and that can be used directly for heating applications or for the electricity generation, etc. Now, there are a number of new technologies available. For example, gasification. In simple words, we can say that gasification means simply converting your solid fuel, that is biomass, into a gas. So once you produce a gas or a syngas, and that can be used for the various applications. We can see some of the applications later. Similarly, torrefaction. So basically from the biomass, or we kind of drying of that biomass, then also you can produce the biochar, which is the solid fuel. Similarly, pyrolysis, again, we can simply say that this is heating the biomass without supplying in any oxygen. So simply you will be able to produce the bio oil and the solids and etc. So as you can see that there are number of technologies available, and converting this biomass into a different fuel, as well as the different energy sources. It can be like heat or electricity, etc. And again, when you're talking about the biomass, one of the advantages of the biomass is that from the biomass we can produce different types of fuel. Biomass is the only energy source from which you can produce the solid fuel, you can produce the liquid fuel, and also you can produce the gaseous fuel. And of course, there are a lot of other advantages which I'm not going to discuss here. Similarly, the chemical conversion, as many of us are familiar with the transesterification or biodiesel production using biomass. For example, in Thailand, the palm oil is used to produce the biodiesel. Similarly, the biochemical conversion, and there are the well-known advanced or the well-developed methodologies like anaerobic digestion or biogas production, and of course the alcoholic fermentation, or in Thailand, like ethanol is produced using cassava, etc. And there are, of course, new technologies like microbial fuel cells and photobiological hydrogen production, etc. So, as I mentioned, there are many technologies. Some are well advanced, well developed, and some are still in the research and development stages. Similarly, there are many different types of biomass. So finding a proper match of the technology for the particular biomass is very much important to have a successful deployment of that technology. Now, I have just tabulated this one, but I am not going into the detail. So as you can see that for the different technologies, there are advantages as well as still there are a lot of limitations. Mostly, as you can see, that limitations are in terms of mainly the high cost or high energy requirements, the thermal efficiency or less efficiency, and etc. And of course, similarly for the biochemical conversion methods, also there are a number of advantages as well as the limitations. Considering the time constraint, I'm not going into more detail. The point is, there are a lot of advantages. Of course, similarly, there are still a lot of limitations among the many of the technologies developed so far. Now, I just put this one to show you that, okay, yes, we have seen that biomass to bioenergy. Similarly, the bio-waste, again, this is the point I want to emphasize. So when you talk about the biomass, it is the different types. It can, even the bio-waste is considered as the biomass, or the biomass coming from the forestry residues or agriculture residues and etc. also considered, or the municipal solid, or at least the organic fraction of the municipal solid can be considered as the biomass. So similarly to what we have seen earlier, the biomass, the bio-waste, if you consider the different types of, the municipal solid waste, or even animal waste, food waste, or industrial bio-waste, or pulp and paper waste, all these can be again considered as a biomass, as a resource which could be converted into various forms of bioenergy, and that would be used for the various applications based on the different technologies as shown here. Now, considering the BCG model, yes, I think that how we are going to link it here. So when you talk about the bioeconomy, yes, we can easily link with all the different biomass and the biotechnologies and etc. We can think about all the different types of biomass, where there is a forest residues or agriculture residues or etc. So when you want to think about the circular economy, mainly we are thinking about the minimizing waste, or at least using the waste, or recycling or reusing. Then easily we can think about using this waste for the energy purposes. And of course, the green economy, specifically we think about using the green energy or renewable or energy, and then the producing algae using this renewable energy like solar radiation, and then the wastewater and the carbon dioxide, etc. So we can think about in terms of various biomass sources or biomass resources which can come from this various economic model, and that could be easily converted to bioenergy and use. But as I mentioned earlier also, the major issue here is the selection of proper conversion method for converting the particular biomass into the bioenergy. These are some of the emerging material. Of course, microalgae, many of us know the microalgae, which has a good carbon dioxide absorption, and again, using the photosynthesis process or solar energy and the carbon dioxide, and again, another waste and the wastewater, easily we can produce the microalgae, and that can be used for the energy purpose. And also lately we are talking about the aquatic weeds, so many of these weeds also can be used as a resource for the bioenergy. Now, one of the advances is the hydrogen production from biomass. Biomass and the waste, as I mentioned earlier, this can be used as a input to produce the viable hydrogen. As all of you all are talking about the hydrogen economy, hydrogen is going to play a very important role in the future. So here, normally, conventionally, hydrogen is produced from the fossil fuel, natural gas, and etc. So here we have a chance using the biomass, simply converting biomass through the gasification process, producing the syngas, and then using the water gas reactor, etc. Then using the processing absorption, we can easily produce the hydrogen. So when you're talking about the different advanced the engineering or technologies or process, most of these technologies are the technically possible, but the main issue is, as some of you aware, that is mainly whether these technological procedures are the economically viable or not. And more importantly, considering the energy conversion, we always look at what is the net energy. In many of the R&D which is going on, where we are trying to convert from biomass into some other form of bioenergy, we may end up in using more energy than the output energy. So the most of the research is relevant to making an energy efficient conversion method, so that our the net energy or will end up with more surplus energy. So the hydrogen is one of the advanced the bioenergy conversion method. And of course, as I mentioned, the microalgae, which can be cultivated from the wastewater and carbon dioxide and sunlight, etc. And again, that can be converted into various forms of energy. We can get the bio-oil, or even we can convert it through the gasification. We can get the syngas, then we can get the hydrogen, and that hydrogen can be used for the the fuel cell and etc. So we have a number of technologies again which could be used to convert this microalgae into the various bioenergy forms. I already mentioned about this, the production of microalgae on increased efficiency, and also this is there's no threat to the land-based plants, and so we don't have the food versus fuel issues and etc. And also the microalgae possess highly effective cellular system for harvesting solar energy, etc. Now, while we already heard about the biorefinery, yes, when we are talking about the bioenergy, biomaterial, and a number of the other value-added products. So biorefinery is the only way forward for the BCG economy. So considering all these three different economy we are discussing, easily the converting biomass feedstock through a number of physical, chemical, and biochemical, thermochemical process, we can convert into the multiple products. as well as we may end up with the different fuels and the chemicals, and of course the energy. So the whole idea is to kind of enhancing and integrating and end up with the enhanced resource efficient system and the usage. So while converting the collecting of all the different types of biomass, whether it is the agriculture residue or forest residue or the waste available, etc., which could be used to not only convert into bioenergy but also the various products and chemicals and etc. By that we can increase the usage of the resources, which the previous speakers highlighted about this, the number of activities carried out in Thailand about the biorefinery. But I just would like to end up with my presentation with one of the futuristic microalgal biorefinery approach for an energy efficient, sustainable biorefinery. Basically, this model also focused on reducing, recycling, and reusing the liquid effluents as well as the solid residues under the circular bioeconomy, and also utilizing all the different types of biomass feedstocks, whether it is a lignocellulosic waste or food waste or agriculture waste, etc. And also in the process, minimizing the amount of use for the microalgal production, so that this can be an ideal model where, as we can see, the converting waste into various bioenergy here. So we can try to use all the different types of waste, whether it is the domestic solid waste or whatever, or municipal solid waste or agricultural solid waste, etc. And also from the different waste we can also produce the microalgae or microalgae cultivation. Then we can produce the microalgae, and of course from these the different microalgal biomass and the various other waste available, we can easily come up with the different biochemicals and chemicals and thermochemicals, and of course fuel and the bioenergy using this biorefinery concept. So, and again, I thought of just to put this one slide about the sustainability issues. Again, often we have to remember that, yes, sustainability of bioenergy is a complex topic. While there are a number of the potential benefits of using biomass for bioenergy purpose or the biomaterial and other purposes, of course, there are a number of potential negative impacts also using biomass. So I just thought of putting this one. I'm not going to look into much details here. So overall, the conclusion is, yes, bioenergy is promising, clean and renewable energy, and applications of bioenergy products are promising in improving energy efficiency and mitigating greenhouse effect. There are a number of conversion processes available for converting biomass into bioenergy. But in my personal opinion, the major challenge for the biomass to bioenergy is the supply chain management, how you are going to the collection and transportation and storage, even the feeding of this biomass into the particular the refinery or furnace and etc. So these are the major issues in the case of the biomass to bioenergy. Of course, the technological development, technology related issues are there, but apart from the technological issues, apart from the less efficiency and the higher cost of production, the major issue challenges the supply chain management of the biomass for the bioenergy production purpose. Thank you very much, and that is the end of my presentation.
Thank you, Professor Sam, for guiding us through the various initiatives and advances on bioenergy in the context of biocircular green economy. especially from the academic and research perspective. We have with us Mr. Kittipong Lim Suvarnarot, Chief Executive Officer and President of the BBGI Public Company Limited. Mr. Kittipong served as Chairman or Director of several bioenergy companies in Thailand. His leadership position include the Managing Director, National Energy Technology Center, Director, the Institute of Industrial Energy, the Federation of Thai Industries, Vice Chairman, Engineering Institute of Thailand, Chemical and Petrochemical Engineering, and Director, National Center for Genetic Engineering and Biotechnology, or in short, Biotech, and Managing Director of Plastic Institute of Thailand. Mr. Kittipong will speak on bio-circular clean economy model in bioenergy applications. Mr. Kittipong, you have the floor, please.
Can you hear me? Hello?
Yes, yes, we can
Okay,
hear.
sorry. Yeah, I think first of all, I would like to apologize that our group CEO, Mr. Chaiwat, he could not join for this session this afternoon. He got some urgent matters, but it's my pleasure to be here to update you on the BCG economy model in bioenergy application, especially on the Bangchak Group experience on this kind of bioenergy application. So may I share my slide on this one? How to share here? Can you see my slide?
Not yet, not yet.
Can you see my screen?
Not yet.
Hello? Not yet. Okay. Window. Give me a second. To share here. Nope, it doesn't show up here.
พี่มีลองกดสีเขียวอีกรอบหนึ่งได้ไหมครับพี่มีลองกดสีส้มอันนี้อีกทีได้ไหมคะแล้วก็เดี๋ยวกลับไปที่หน้า Internet Explorer กันนะได้แล้วค่ะสีส้มสีฟ้าที่ได้
Okay, you see the screen now?
Coming, not yet. Okay,
Hello?
we can see now.
Hello?
We can see now.
Nothing coming up.
Yes, yes, we have seen.
Okay, thank you very much. Okay, this is the. Let me start with the. This is the BCG for Thailand, right? They're talking about our Bangchak group. We also been communicating on within our group on our focus on the bioeconomy, as well as circular economy, as well as green economy. So this is something that we are working at within the group to share our what activities regarding the BCGs. And in our models, we adopt the UN SDG goals with the UN SDG goal together, and that we are primarily focused and adopt on, and we prioritize some of them, and we have the second tier as well. So we are committed that we will become the net zero by 2050, and we reach the state of the carbon neutrality by 2030. So that is our strong commitment in these areas. And last year, we also initiate the carbon market club, which is a voluntary group of people and the enterprise carbon society toward the net zero society as well. This is the BCP portfolio, how we accelerate ourselves on the green portfolios. So let me show you the case study, how we start on the new S-curve on the business. So we start to transform the BCP group portfolio from the fossil-based business to the green business portfolios. And you can see on the top pie chart that we started in 2021, our red color is a fossil business. We have about 60% of the fossil business, whereas we have only about 40% of the green business. Our direction to be 50-50 of the fossil business and the green business within 2030. And by 2050, we will have the less fossil business, less than 30%, and majority of the Bangja Group business will be more on the green business. On the lower chart, you can see that when you look at the curve of how the fossil and green business cross over, most of the industry fossil business will have that kind of direction to cross over by 2035 to 2040. But in terms of the Bangja Group, we are aiming to reach that target by 2030. So that is very ambitious target for the Bangja to move in this area. I would like to share with you on some of the initiatives that working on for bio product for the Bangja. Based on we have the bioeconomies. You can see on the left-hand side that this is what we starting with. So in the 2015, we are probably the first one who introduced the biodegradable plastic cup for our internees, the coffee shop. At that point in time, we had about 400 to 500 outlets across the country. And even though by that time, the cost of the biodegradable cup is very expensive, it's more than 3 times higher than the normal, the conventional plastic. But because what we believe in the sustainability world, we decide to go into the environmental friendly option. So we adopt that biodegradable plastic by that time, 2015. 2018, we start to look at the initial initiative that we think that we may be to expand more into the biotechnologies. That's why we are starting a company called BBGI. BBGI is a bio-based green innovation, and this is the flagship of the Bangja Group on the bio-based product. BBGI at the beginnings, it is the biofuel producer for the Bangja Group. We are making the bioethanol and biodiesel, but we believe that we can move further by consolidating business and start to venture into more the bio-based product with the concept of biotechnologies beyond biopower. Through BBGI, we set up the forum called Thailand Symposiums, Thailand Bio Symposium, and that is happened in the last years to build a network of the business that can utilize the synbio or synthetic biologies, which is what we are believe that is going to change the world. With the technology, we can create anything from the laboratories using the microbe and can make the finished product. And we can transform our sugar, which is the first generation sugar that you are familiar with, into anything that we might need, from the cloth, bioplastic, biomaterial, pharmaceutical product, or even it can be the cosmetic product, such as collagens. This product can be made in the lab, and it is can expand to be the commercial product. And from that a little idea of using biodegradable cup, we are expanding and scaling up into the biotechnology company. And you will see this development in our group within the next couple of years. Another example of the circular economies. As for the circular economies, back in 2010, Bangja Group, we are the very first one. It's an example of the circular economy. And in 2010, at that time, Bangchak is very well first to recycle the cooking oil. And at that time, people can donate or sell the used cooking oil to the Bangchak service station. From that, we collect the used cooking oil and mix them with the current crude palm oil and solidify palm oil and turn into methyl ester, which is we call the biodiesel or B100. And we use that B100 with the diesel to become the biodiesel product. That in that 2010 time frame, every day we collect 100 liters of the used cooking oil, and it was a small operation. 15 years later, 2014, in the next 2 years, we are working on the sustainable aviation fuel, or the SAF, and we start to having a project that we gonna correct the used cooking oil in Thailand and refine the oil and use the oil as a biojet fuel. This is an ongoing project, and we are aiming to be the first largest SAF producer within a couple of years. This is the big difference from what we are starting in 2010, and we start to going from the used cooking oil, and now we are able to turn that project into the future, the biojet product. Another one, can you see the screen, right? The green economies.
It is circular economy.
Still circular, right? Okay, yeah. I don't know.
You need to move next one. I saw next one.
You see the next one already?
Oh, no, I saw in the small slide is green, circular, but please move.
Circular, and I move to green.
Please move to slide number 7. Now you are number 6.
Yeah, I moved to number 7 already, but somehow it doesn't move in your screen. What can I do now? I stop.
So we can help you. Excuse me, we can help you.
Can you manage over there?
Yeah, we can do it for you.
Okay, thank you very much. That may be better. So we are at the slide number 7. Can you see number 7?
One second, please. Yeah, we are number 7 now.
Okay, good. This is another example of the how we convert from the green economies using the biodiesel. So what happened is in 2009, we start to have the new biodiesel plant, the first time in Thailand. And we are the first integrated biofuel producer that we are making the diesel for the product, for the gas station in Thailand. And right now, we are integrated for both bioethanol and biodiesel, as well as the refined gasoline production in Thailand, with a total capacity of almost 1.8 million liters per day. So that is something we are committed to, moving from the clean product from biodiesel and expanding to bioethanol and biodiesel with the refined glycerin. So if you move to the page number 8, are you on the page number 8 now?
Yes. Yes.
Okay. This is the way of showing you the roadmap from the ESG to the business platform. And you can see that from the beginning, we are the agriculture co-op service station in 1990 under the Oil for Rice project. And we start to working on the CSR in progress, and we start to have the gasohol and biodiesel offering in 2010. And after that, I think the Bangchak group, they start to look at the Bangchak BIIC, which we call the Bangchak Initiative and Innovation Center. This is the new set up organization to working on R&D as well as corporate venture capital to develop the ecosystem and incubation for the new product, especially on the clean product. And as I mentioned before that 2017, we start to working on the biodegradable crop. And 2020, now we have the Winonis. Winoni means the motorcycle driver doesn't have the debt anymore. So this is the e-bike rental service platform. And that is something we start, initial start in 2020. And we shall target to provide the service to at least 2,000 to 3,000 users in 2022 before expanding to 20,000 users in 2025. And we really focus on the carbon neutrality. We commit to have the carbon neutrality by 2030, and we are going to aim for the net zero by 2050. And the last one, which is maybe the first stepping stone for the SynBio technology in Thailand, we are aiming to be the first CDMO who are able to scale up the SynBio technologies in Thailand, and that we are working on the development of this one, and we are probably be able to announce all the new development by the next quarter. So we move to the last part is next page on the page number 9. Are you on the page number 9 now?
Yes.
Okay, and this is what I mentioned before that BPI, we would like to be the leading in the bio-based green innovation for the sustainability. So, and I mentioned before that we are transforming ourselves from the biofuel product, moving to the high-value bio-based product. Next slide, please.
Yes.
Okay, this is the example of how we transforming ourselves from the leading biofuel to the high-value product. So we are expanding with the product using the synthetic biology technologies. And you can see that in the future, our portfolio will come up with a different kind of product. And that is the new biotechnology that we are expanding for Thailand. The next slide on the page number 11. This is the graph that shows that why we are aiming to expanding our product from the biofuel to the more high value added product, for the reason that the product we are on biofuels, they are high volume, but the value is about $1 per kilogram. But when we are expanding to the biochemical, biomaterial, or even to the biocosmic, bionutrition, the value chain will be much higher. Even though the volume will be less, but there are a big attractive for the new product development. If you move on to the slide number 14, this is the way we are working on the BCG model in Thailand. And you can see that in the triangle, it shows up the same kind of the value chain, that the bottom is a biofuel. And if we are moving up to the value chain, the value of the product will be higher. That is something we try to focus on. So we are using the left-hand side, which is agriculture product, and or even to agriculture waste. And we are working with the R&D to develop technologies. We are working on the optimization and working on the research development. And at the same time, I think we are aware of Thailand is lacking up the scale-up facility for commercialization. So how to bridge the gap between on the left-hand side to the right-hand side to get the more commercial product through the technology and facility to scale up. This is the way that we are developing in Thailand right now. On the page 14 is the what I call is the bottleneck of the whole industry for the biotechnology. So far, we have many biotechnology companies in the world, and what happened is they are able to develop the microbe. They are able to develop the genetics pathway. They are able to do the microbe engineering. But what the bottleneck in the industry so far is they are not able to scale up in the commercial production volume. So this is the global bottleneck of the biotechnologies, especially on the core precision fermentation. So this is the way that BPI and the Branchak Group is try to work on this project. Case 15 is something on the Thailand SynBio roadmap. So what really happened is the Thailand's government sector as well as the industry sectors, we would like to aim for Thailand to be the synthetic biology hub. And there are big opportunity that based on the diversity of the feedstock, based on the way that we are able to work on the scale-up facilities, Thailand can be the one of the hub in the Southeast Asia. And what really happened so far is the government already set up planned the program to have the multi-purpose biorefinery, the pilot plant in Thailand, that will be on the eastern seaboard. And they are working with a partner, which is Biobase Europe, to develop what they call is a pilot plant to be able to scale up to 10,000 liters. And that will help and support on the how to scale up facility in Thailand later on. At the last page, I would like to share that from the industry perspective, BPGI under the Branchak Corporation, we are aiming to support the industry to be able to have the new ecosystem in Thailand. And what we are developing right now is we are developing the platform, which is the new advanced synthetic biologies. And that is a platform will help to scaling up the bridging of the product under the R&D research, be able to scale up in Thailand and commercial the product to sell in domestic and overseas. So that project is going on right now. And by 2024, I think the commercial operation will start up by that time. So that's the whole picture of what the Branchak Group and BPI, which is bio-based clean innovation under the Branchak Group, is developing right now for sharing. Thank you.
Thank you very much, Mr. Kittipong, for sharing the bio-based green initiatives for sustainability of the BBGI Public Company Limited, which integrate SDGs with business operations, accelerating green portfolio of programs and transforming from leading biofuel to sustainable high-value products. So we thank all of our distinguished speakers for their insightful and fascinating presentations. Now we will move to panel discussion session. Ladies and gentlemen, we are now into the panel discussion segment of the seminar. I call on Professor Dr. Mario Tabukanan, Emeritus Professor, Asian Institute of Technology and Visiting Professor, United Nations University Institute for Advanced Study of Sustainability, to serve as moderator for the panel discussion. Professor Mario, please.
Thank you very much for the kind introduction. And please join me in welcoming the panelists. We have with us Ms. Sandra Averos Moneri from UNEP. We have Professor P. Abdul Salam from the Asian Institute of Technology. We have Mr. Kittipong Lim Suwanarot from the Branchak Group. Dr. Korojit from PTIT is unable to join us, but he shared in advance with me, which I will share with you momentarily his thoughts about the issues in the panel discussion. Professor Pisut, Secretary to the Minister of Energy, is unable to join us, all very busy people. But before we proceed, I would like to invite all of you to have a screen shot. And let's start with the panelists first. Please open your video camera. Video camera, starting with the panelists first, and then the rest of the participants, just for a few seconds. Now, we heard from the speakers talks about processes, about methodologies, about programs, projects, outcomes, with regard to the application of the BCG economy model. And they were all very insightful. We learned a lot from them. But as we look at the UN 2030 agenda and the SDGs, these require strong alliances between the scientific and academic community, the business sector, the government sector, civil society, international organizations, and a multitude of stakeholders are at play. And the interplay of science, practice, policy, and society, the so-called science and evidence-based policy making, is very essential in what we do. So I would like to focus our panel discussion on the enabling mechanisms, the policy enablers in particular, that help unlock, accelerate, and scale up biocircular green actions. And so that's my first question to the panel is, what are your priority policy recommendations for ensuring success in implementing BCG in the bioenergy, biomaterial, and biochemical sector? That's the question. And let me start with our friend from the private sector, Kon Kitipong. What is your view on this? Kon Kitipong. Kon Kitipong, can you hear me? Unmute, please unmute yourself. Kon Kitipong, would you please unmute yourself?
I already unmute. Can you hear me?
Yes, now I am. We can hear you now.
Okay. I think the priorities of policies for ease of doing business, especially the BCG model. And when I'm talking about the biotechnologies, which is the new things in Thailand, especially when we're talking about synthetic biologies, sometimes it's going to be difficult for the government sector to understand what will be how to manage and how to support the industry to moving to that kind of the advanced biotechnologies. So the policy to support, for example, when we are making the strain, importing the strain or developing the strain to produce the product, there are some potential understanding bottlenecks for those from the FDA that they may not understand the advanced technology of this kind of things in Thailand. So understanding that kind of the development of the industry sector so require the bridging gap with the government as well. So that is one of the examples that I believe that how to do or how to make an ease of doing business, especially in the new advanced technologies that require a lot of closely collaboration between both industry and private sectors, in government sector together to drive that kind of the activities to the goals.
Thank you. Well said. Thank you very much. Professor Salam, what is your view on this, especially from the academia perspective?
Yeah, thank you. Once again, thank you for the opportunity. While we are discussing about the enabling environment or the policy recommendations, yes, the academia point of view, yes, definitely we should have more and more capacity building and activities. As you know that these we are talking about some of the new technologies, so it is very important not only for the technologists or engineers to have an idea about what we are talking about, but also more importantly, the policymakers, the champions who are going to make at the end of the day policies to, enable these activities to happen. They should have a very clear idea about these different issues and the impacts and the implications, etc. So the capacity building is definitely an important issue. And as I mentioned, not necessarily at the technician engineers level, but also the policymakers levels. And other than that, and very importantly, since these again, we are talking about new technologies, the technology transfer related issues, the earlier speaker has touched upon a little bit. But more importantly, it is very important to identify and entrust the institutions to take these activities as the champions to go ahead and deploy these technologies. Thank you.
Thank you very much, Professor Salam. Yes, capacity building not only of individuals, but also of institutions, of organizations as well. Well said. Thank you so much. And let's hear from Sandra. Sandra, can you speak on behalf of the international organization?
Yes, can you hear me? Can you hear?
Sandra?
Yes.
Yes.
Can you hear me? Yes, okay.
Yes, no, we can.
Wonderful. Maybe I'll follow up on just the previous intervention on capacity building and refer to education and the importance of education, not just for the engineers of a country, but also education at large of the public sector, within companies, private sector, of the consumers as well, but obviously within university and engineer curricula, to make sure that the environmental dimension in particular and sustainable development is at the heart of the policies and at the heart of this education. The bio-circular green economy model, as it has been explained today and over the past year, is really speaking to it. And I just wanted to highlight one point, which is a month ago, the UN General Assembly has actually come to a resolution that saying that access to a clean and healthy and sustainable environment is a universal human right. So it's definitely within this model that we're discussing today, and it's important that it remains in its application. And in terms of policies in particular that could be supportive or put in place, I think we highlighted the importance of having the different stakeholders together and having policies that and processes that favor that will help strengthening the discussions and knowledge between science and policymaking, linking further the research agenda with the development needs of the country. So supporting also with some market-based instruments the development and the scale-up of promising technologies. So these are a few elements that I wanted to.
Yes, thank you very much. Thank you. It's not only education on sustainable development on BCG, but education for sustainable development. We have to rethink, revisit our educational system and pedagogies and other issues related to education. I would like to share with you the take of Dr. Kurajit. He has 3-point recommendations on policies. Number one, to liberalize more on the electricity market structure to allow the private sector to participate in electricity trade among themselves, which would allow smart grids to become a reality. So the producers of bioenergy could sell it to the grid, and then it could be traded across the board. So that's one recommendation. The other one is to have a clear direction to go biofuels promotion or electric vehicle promotion. They sound like conflicting in the first place, but they may not be. They could be reinforcing each other. So policy that would reinforce biofuels promotion vis-a-vis electric vehicle promotion. Second recommendation. The third one, which relates very much to Professor Salam's presentation about biorefinery, because biorefinery should be given more tax incentives, investment incentives to turn innovation into commercialization. And this is very much so in order to translate or transform biomass into high-value products. All right, the second round of questions, let me see. It's on the way to 2050. We still have time, yes. On the way to 2050 for carbon neutrality for Thailand, or 2030 for the SDGs, there would certainly be bumps on the road. It's not smooth ride. And so it is important to anticipate, to identify the impediments, the barriers, the challenges that we have to overcome. So my second question is, drawing on experience both from Thailand and internationally, what are the impediments or barriers that must be overcome to achieve successful implementation of programs under the BCG? So, private sector, Kun Kitipong, what is your view? Kun Kitipong, are you still there?
I just unmute now. Sorry about that.
The impediments.
In my view, in my view, I think in line with Dr. Kurujit has mentioned before, we are entering into sometimes new areas, and there are some potential conflicting in terms of direction. So there are hurdles that may happen from that kind of the path forward. So it is what I call is a clear understanding on the roadmap. If we want to go from here to there, what shall be the potential outcome or potential roadmap that we agree on both industry and the government sector? For example, nowadays people talk a lot on the biojet, and we talk about the SAF, sustainable aviation fuel, and this is something new, even new to the world as well. There are no clear direction from the government. This is something that they would have to support or not. This is the same thing that in the last 10 years, government support for the biofuel, because they believe that they want Thailand to be self-sufficient, don't have to rely on the crude oil import to the country. Within 10 to 15 years, now they move to the EV direction. And what happened to the biofuel industry? What can they do about it? On what is the direction? Nowadays, people try to get for new high value added based on the infrastructure or the asset that they have today. So those are something that I believe that this is a hurdle of the clear, wrong policy to support the direction of the countries.
Thank you so much. Thank you. Professor Salam?
Yeah, thank you. So since we are talking about the successful implementation, and as we have seen earlier, the successful implementation of BCG models very much depend on the resources availability and the technology, and of course the enabling environment. And of course, Thailand is working on all these, and Thailand is developing a lot of new technologies and coming up with the enabling environment. But often I come across this issue when it comes to the resource availability, especially when you're talking about the new and renewable energy resources and etc. I found that most of the time the assessment or the estimation of this resource availability is almost always an exaggerated, or many times we found that we on papers we see that okay, there are so much resources available, but when it comes to the implementation we found that these resources are really not available. So my concern is related to the estimation and the availability of these resources. And of course, as I mentioned, the all other issues also concerned, but this is the most important issue, the availability and estimation of the resources, and especially and specifically when it comes to the biomass. As I mentioned, these resources may be there, but the supply chain management and, for example, collecting and transporting, storing and distributing, taking from the resource availability point to the point where it will be used, it will be really a problem, and that has to be kind of concentrated and solved.
Thank you very much. I think the resources is very important. Sandra, you have something to add on this?
Yes, maybe 2 points. The first one, in particular in chemistry, we always talk about regrettable substitution, and I would say it's certainly a major challenge. So making sure we apply principle in planning for these road to 2030 or 2050, including the precautionary principle, including the product stewardship. I think that would be really important to overcome this challenge. And the other point or suggestion is also to make sure we have both pull policies, so that help, push policies that help driving the new idea and supporting the new sustainable idea, but also pull policies so that there is a stimulation of the market demand. And we know how much the procurement and the public procurement represent a large share of the GDP of a country, between 20 and 30%. So this is also creating a market demand for these new models.
Yes, thank you. So a lot of resources, especially financial resources, unclear targets and goals, as mentioned, unclear understanding of what BCG is all about, lack of strategy. These are all compounding the issues. And it is important that regions, for example, in other parts of the country, other regions are also conversant of what BCG is all about. So let me go to the final question, since time is already very tight now. In these impediments down the road, there are opportunities, of course. There are areas where we can put resources and make BCG investments in. So my third question and final question is that, drawing on experience from both Thailand and internationally, what might we expect to be areas that offer best opportunities in the sector, opportunities offered? Let's hear from the private sector. Mr. Kitipong.
Yes, for the BCG areas, I think there are few product or area that people start to get into this area. For example, Thailand start to working on the bioplastic production in Thailand, and that is a new opportunity using the bio-based product feedstock and start to make the bioplastic. You have the nature work and also have the carbon. They are expanding and implementing the bioplastic on the world scale basis in Thailand. That is one of the opportunities that I see. Second one is on the area that I mentioned about the synthetic biologies. This is a new thing in the world, and this is a new opportunity in the worldwide basis as well. Thailand is not far behind on that kind of knowledge. And I believe that that is a new area that's going to be advanced biotechnology for Thailand market and for as a base for the expanding to the region. And the third area that I am foresee more is on upgrading the biofuel product to the sustainable aviation fuel or the biojet. This is a new opportunity that the world is requiring capacity or the supply of this product. And Thailand have a lot of the opportunity in this area as well. So from the bio-based and circular and clean, so this is a big ticket item that I foresee right now.
Okay, thank you so much. Kun Kitipong, Professor Salam.
Yeah, I think Mr. Kitipong already explained. I mean, he is very specific, and especially Thailand is very well ahead in the region thanks to some of the policies adopted by the Thailand, well, about 20 years before. So the Thailand has a lot of opportunities. Thailand can be a leader in the region, and more specifically in those two issues related to the bioenergy and the bioproducts, as the previous speaker mentioned, the more detail related to different types of bioproducts.
Thank you very much, Ms. Sandra.
Yes.
Yes, you may add something.
Yeah, I'm happy to maybe just refer to the framework manual that I presented earlier and highlight that there are a number of innovation opportunity highlighted at global level, including the bio-based and renewable chemicals fixed feedstock, including some chemicals innovation opportunities, definitely related to plastics, but also surfactant, for example, or preservative. Some process innovation opportunities that we've heard also about today, including biorefineries, and probably highlight that an underlining need or principle would be to ensure digitalization and information sharing along the supply chain and the value chain to advance the green and sustainable chemistry and sustainable development overall.
Thank you very much. Let me share with you the thoughts of Dr. Korajit. He suggested that government should be consistent in supporting investment decisions by the private sectors. So government should support private sectors, especially those who participated in the BCG economic development model implementation and other areas of opportunities that Dr. Korajit mentioned to focus on are carbon pricing and domestic carbon market, smart grids and energy trading platform, biofuels, efficient productions, improve crop yields because agriculture is the supplier for all these biomasses, and modern biotechnology for crop production and bioplastics. So those, I think, are very much reinforcing these ideas of how to proceed, how to advance BCG in implementing it in the bioenergy, biomaterial, biochemical sectors. So let me share with you the moderator's take. Policymakers should actually establish BCG economy roundtables. Not many government departments know about what BCG is all about. So to establish roundtables across government departments to serve as platform for networking, for knowledge exchange and innovation. And policymakers, I think, should also be responsive to have a flexible policy design, which is based on evidence, based on science. And as mentioned by Professor Salam, I think policies effectiveness should be assessed and redesigned if necessary. So the assessment of policies effectiveness. I think businesses should also partner with the various stakeholders to participate in pilot projects and to explore new investments in BCG and establish or mainstream BCG policies into company policies. Establish company-wide commitments to BCG economy and internally and externally. As for international organizations, they can assist in knowledge sharing. Experience from other countries should be shared with other countries as well to learn from them and assist in and supporting upscaling actions on BCG. Academia, as mentioned earlier, should raise awareness, build capacities and competences, and engage in research and innovation. So I think we all agree that effective policies can help accelerate and scale up bio-circular green actions in the economy. So there is a clear pathway, as we discussed. The issues are known, and it boils down to the theme of this seminar, which is awareness raising, capacity building, and learning from international perspectives. I thank you all, the panelists, the three panelists on board, as well as the speakers who were unable to join us in the panel, for sharing insights on BCG and its implementation in the bioenergy, biomaterial, biochemical sector. So with that, I would like to end up the panel discussion and revert the floor back to the seminar moderator, Dr. Montip, please.
So thank you very much, Professor Dr. Mario Tabukanan, for sharing the panel discussion session. I think we have learned a lot from this session. Now we have come to the end of the seminar. It was a productive and insightful seminar with valuable information shared and discussed by all speakers. In this seminar, we focus on the bioenergy, biomaterial and biochemical sector for implementing the BCG economy model. The process of implementation would entail building capacities of human resources of the BCG economy methodology and practice. This would require investments in science, technology, research, and innovation, especially in the bioenergy, biomaterial, and biochemical sector. So learning for sustainable development at all levels is an important infrastructure for transformative. Raising awareness, building capacities, and learning international perspective on BCG economy model at local, national, regional, and global forums are essential. The role of the United Nations through its various agencies such as UNEP and others, as well as other international and non-government organizations, academia, and the private sector are essential in accelerating and upscaling programs and projects to the national level and other regions of the country. We aim at taking lessons from this seminar and provide recommendations to authorities and policy makers on the policy implementation, challenges, opportunities towards advancing the implementation of the BCG economy model in the bioenergy, biomaterial, and biochemical sector, and provide possible inputs to the upcoming APEC summit hosted by Thailand in coming November this year. We will continue our discussion in this seminar series. The next seminar to be held in the later part of this next month, which is the fourth in the series, will focus on BCG economy model in the tourism and the creative economy sector. So keep posted. So we conclude the third seminar. We very much appreciate your participation and we look forward to seeing you again soon. Thank you very much. All the best and stay safe. สวัสดีค่ะ